Okay, welcome back. We're doing section exercise 4.2. You'll find that on page 117, Active Maths 3. We're asked to square the first 10 whole numbers. That's something we can do in our head. So let's square 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The way I write, I would not be comfortable writing 10 columns in one row. Now you might beg to differ. Square of 1, square of 2, square of 3, square of 4, square of 5, square of 6, square of 7, square of 8, square of 9, and square of 10. Now you're reaching the limit of what you'd be comfortable squaring, and you could have used a calculator for that. I just want to show you how you would do that. You would keep the variable at the base and you'd square it. So let's just say for argument's sake you had to square from 10 to 20. With steps of 1 you would do it that way. Okay. Now looking at the next question, we notice that they're using what we have just calculated as the inputs to square root. And what they're getting at is that square rooting is the opposite to squaring. If you want to undo squaring, you square rooting, your square root. Think of it as this: the number that's squared gives 4. Well, we know that it's 2. So you're literally finding 2, 3. Square root of 16, 4. Square root of 25, square root of 36. Just one simple extra point is that when we talk about the number that's squared gives 81, there's actually two answers. -9 or +9 would have been answers. So when we say the square root of 81, we're talking about the positive answer. It's not just understood, it's by definition. It's always a positive answer. Now they want us to cube. Now we discussed this somewhat in class. Can you cube in your head the first few numbers? Well, 1 cubes to 1, 2 cubes to 8, 3 cubes to 27, 4 cubes to 64. I would say it's nothing to beat yourself up over. It's not a priority. It's nice to know them. 6 cubes to 216. Swap the 2 into 1. We know a power of 6 always ends in 6. 7 cubes to 343. 8 cubes to 512. 9 cubes to 729. And 10 cubes to 1000. But far better, if you don't know them, is to not worry more about understanding and let the calculator do all that kind of work for you. So you got your x and you got your cubed function, and you'll run that from 1 through to 10 in steps of 1, and you'll see all those answers that I've just written down there, and you can check that I didn't make any mistakes. Now next we have cubed root. Well, what's interesting about cubes and cubed roots is what I just said about the square root of 81, or if you're solving x squared equals 81, that there are two answers. That goes away when you're getting cubed root, because if it was a negative, if you had to get, for example, the cubed root of 125, the answer would simply be -5. There's no other answer. Okay. So what we're looking at is the first perfect cubes. So the answers are literally 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So again, these are opposites to each other. Okay, now using, I would rather call that the definition rather than the law, but it's, if you like, 1, 2, 3, 4, 5, 6, law 6 from your log tables. So using law 6 from your log tables, no it's not, it's law 5. Write the following, 2 as fractions, 2 to the -3. Okay, so let's go through these step by step and we'll write out every part. 2 to the -3 equals 1 over 2 to the 3 equals 1 over 8. Okay. two steps. Part 2, 4 to the minus 2, write it down, equals 1 over 4 to the plus 2. So you want to get rid of the negative power by bringing the 4 to the power of underneath and changing it to positive 2. And to do that you have to introduce a 1. And that's over 1 over 16. 9 to the negative 3 equals 1 over 9 to the positive 3 equals 1 over 729. 9 cubed is 729. 5 to the negative 3 equals 1 over 5 to the 3 equals 1 over 125. You can check any of these you like on your calculator. Bring it back to calculate. 5 to the power, now here's where you're going to have to use this. You can't use your cubed because cubed is plus 3. 5 to the negative 3. Negative 3. And sure enough, it just comes up with 1 over 125. You might argue that, well, why don't you just use the calculator for these? Because we're trying to develop concept, and the concept won't be developed by just using the calculator. Okay, 6 to the negative 2, and you can see there's a bit of repetition beginning now. 1 over 36, 7 to the negative 2, 1 over 7 squared equals 1 over 49, 3 to the negative 4 equals 1 over 3 to the 4 equals 1 over 81. 8 to the negative 2 equals 1 over 8 squared equals 1 over 64. Hope you're doing better with the. I hope I'm doing a bit better with the iPad today, that you can see both and the video isn't kind of all over the place. I might just keep it here and just use one side. And so on. So we'll move on to the next question. Question 5. So it tells you again to use the negative power rule to write the following as fractions in their simplest form. Okay. 2 times 5 to the negative 3 equals 2 over 5 to the positive 3. So notice how just the 5 to negative 3 jumped down to 2 stays where he is. Equals 2 over 125. There's nothing but 5's here, nothing but 2's here, so there's no room for cancellation. Okay. 3 times 8 to the negative 2 equals 3 over 8 to the 2 equals 3 over 64. 5 times 4 to the negative 2 equals 5 over 4 to the 2, 4 squared if you like, equals 5 over 16. And I'm going to start skipping bits now and just writing answers. Okay, the next bit is 4, or at least I'll save my voice maybe. Four over 81. Now you have to watch out here because there's going to be a 2 cancelling somewhere along the way. We start off with 2 over 8 squared, 2 over 64, 1 over 32, and you will be punished on the marking scheme for not bringing it down if you fail to bring it down. 3 over 7 squared, 3 over 49. 4 over 16 equals 1 over 4. 3's are going to cancel here somewhere. 3 over 6 squared equals 3 over 36 equals 1 over 12. 2 over 4 to the power of 2 equals 2 over 16 equals 1 over 8. And on to question 10, part 10. 10 to the 3, 5 over 1,000. 5 into 10 goes 2. That's 1 over 200. That's it, is it? Okay. Probably homework for Wednesday night there. It's nice to have it done in advance. And we'll push on then to section, hang on a second now, 4.2. I might have missed a page. Okay, let's look. 119, 117. I gotta get page 118 for you. But anyway, that's for the next day anyway. Okay. Thanks for watching.